Okay, in this question the first thing we've got to do is find dy by dx. Here's what y is, and it's the usual core 2 thing that we've got, in this case 1 over x cubed, and we need to express that as a power of x. So you get y equals something involving a power of x for the first thing plus the 48x, and then you're ready to differentiate to get dy by dx. Hence, that means use what you've just done. Find the equation of each of the two tangents to the curve that are parallel to the x-axis. So, if they're parallel to the x-axis, that tells you a fact about the gradient. And the gradient, of course, is dy by dx. So you want dy by dx to equal a particular thing. That will be the gradient you use in your equations. Of course, your equations, the y minus y1 recipe, for that equation you need a point and a gradient. So we already know what the gradient is going to be, but we need to solve dy by dx equals a value in order to find the x coordinates of the points. So for the points we need x and y coordinates. The x coordinates are going to come from solving dy by dx equals the correct value, and then the y coordinates we can come back to this equation to find them. So for each of these two lines we'll have the gradient, which we knew in advance, and points whose coordinates we've worked out, and then we can use the y minus y1 recipe from core 1. And then in part C, find an equation of the normal of the curve at the point 149. This is a re-entry point. As long as you've got dy by dx, all you need for the equation of a normal is a point and a gradient. There's your point. You need to find the gradient. Dy by dx gives you a gradient, but it needs adjusting to find the equation of the normal. Remember, dy by dx is the gradient of the curve itself, and we need to adjust that to get the gradient of a normal to a curve. So you've got a point, you've got a gradient, which is dy by dx for this x value, adjusted to make it into the gradient of the normal.